In a quiet competition, a relentless pursuit to possess the most formidable and advanced weapon of war ever developed in the history of mankind. Powerful nations have left no stone unturned in the development of weapons that are not only technologically advanced and unrivaled but also effective in improving their defense systems. In line with this, Japan has finally revealed a weapon that is one of a kind, a sixth-generation fighter jet. That makes the world tremble in fear and has left Russia in a state of shock upon its announcement. What makes this fighter jet unique? How powerful is this jet in comparison with others? Join us as we explore the features of the sixth-generation fighter jet that Japan just revealed. When a nation recognized for its unmatched skills in developing cutting-edge weaponry teams up with other leading nations in the development of a weapon, other nations have no choice but to watch in awe as these countries birth an advanced weapon that no other weapon stands a chance against. It is no wonder why Russia panicked when Japan announced its new sixth-generation fighter jet, which was developed with the collaboration of the United States and the United Kingdom. This fighter jet, which is a part of the Japanese Air Force and is known as FX, showcases features that have never been seen before in the history of fighter jets. Its development of this formidable weapon started when the United States prohibited the export of the Lockheed Martin F-22 Raptor. Even to allied nations like Japan, this restriction resulted from the 1997 Obey Amendment, which aimed at protecting the F-22 Raptor. As a consequence, Japan found itself unable to acquire the cutting-edge fifth-generation F-22 Raptor. Japan was the first country to deploy the F-2, a fighter jet with an AO radar and an air-to-air air missile guided by the AECA. This was an unrivaled feat because even nations that were leading in the world of weaponry had not been able to develop such a weapon. $23 billion was spent on acquiring 2 squadrons of the F-35 Lightning II by Japan's Ministry of Defense, but they eventually realized that it was about time they developed a fighter jet of their own. Something that was unique to them, and after years of research and dedication, the FX was developed. Japan has been actively involved in producing various American fighter aircraft within its own borders. Some examples include the F-4E Phantom, the F-15 Eagle, the F-16 Fighting Falcon. That was transformed into the Mitsubishi F-2 and the F-35, a Lightning II. These aircraft are currently in service with Japan's Air Force and have undergone significant modifications, setting them apart from their original American counterparts, except from the F-35. Despite Japan's impressive technological capabilities, it was weird that the country had not developed its own indigenous fighter for air-to-air combat since the Second World War. This means that the upcoming sixth-generation jet will mark a significant milestone, representing Japan's first venture into producing such a fighter in decades. In its pursuit of an elegant sixth-generation fighter, Japan aims to surpass the capabilities of existing formidable fighter jets like the F-35, particularly in the realm of air-to-air combat. Japan embarked on its journey to develop an advanced fight by starting with the $350 million prototype that was known as the Mitsubishi X-2. This prototype served as an important step in demonstrating that the desired capabilities for their future fighters were indeed achievable. The intention was to avoid becoming entangled in the extensive development of a sixth-generation fighter that could potentially be perceived as a symbol of weakness. Mitsubishi X-2, however, proved to be a resounding success, overcoming tests from its maiden flight in 2016 till the end of assessments in 2018. This success paved the way for Japan to gather new insights, develop innovative technology specifically for the FX fighter, and formally initiate the FX program. Mitsubishi, a prominent Japanese company, took the lead in manufacturing the FX fighter. Recognizing the magnitude of the project, Japan decided against tackling it alone. Instead, they sought international collaboration to ensure the success of the FX program. This choice stemmed from the understanding that entrusting such a significant endeavor to a solely domestic firm, especially one inexperienced in similar projects, might not yield the desired outcomes. To avoid this, Japan reached out to the United States and the United Kingdom, both of which boasted of their own sixth-generation fighter programs. Proposals were sent to these nations inviting their active participation in the FX project. This collaborative effort was a strategic move to leverage the capabilities of nations with advanced expertise in fighter jet development. Several major players in the defense industry, including Boeing, Lockheed Martin, BAE Systems, Northrop Grumman, and even the British government, responded to Japan's proposal for collaboration on the FX project. However, after careful consideration, Japan rejected all their offers, deeming them not appealing enough for the ambitious project. Even though the UK presented an opportunity to collaborate on the FX project, alongside their sixth-generation Tempest program, and Lockheed Martin offered a unique F-22 and F-35 hybrid fighter, something even the United States didn't possess. Japan was open to collaboration with foreign defense contractors, provided they aligned with Japan's crucial aspects for their future fighters. They were willing to accept collaboration that provided their project with the potential to expand capability by incorporating next-generation technologies and the ability to also upgrade and modify the project with relative ease while keeping it affordable and capable of future air superiority. With these clear criteria in mind, Lockheed Martin was deemed qualified to offer technical assistance. Simultaneously, discussions were underway with Britain's Rolls-Royce to supply the jet engine, while Mitsubishi focused on the airframe design and system development. This collaboration was estimated to come at a considerable cost of about 5 trillion yen, or $48 billion, as the collaboration progressed. Indications pointed towards the development of a fighter that would possess the most advanced technologies. From three of the world's most powerful nations, the features of the FX fighter hinted at a remarkable fusion of capabilities, showcasing the collaborative efforts of Japan, Lockheed Martin, and Rolls-Royce in creating a fighter that aimed to redefine the standards of air superiority. The ambitious venture not only highlighted Japan's commitment to technological excellence, but also reflected a collaboration that promised to deliver a fighter at the forefront of global military capabilities. The Mitsubishi X-2 played a very important role in propelling Japan into the development phase of the FX fighter. Its success not only validated the feasibility of their envisioned capabilities, but also made the groundwork for collaboration with external partners, with Mitsubishi leading the charge in shaping Japan's path to creating a formidable sixth-generation fighter. The Defense Minister of Japan, Taro Kano, shared details about the new aircraft, laying emphasis on its stealthiness, network-centric features, and increased missile capacity compared to that of the F-35. The FX aims to surpass the capabilities of the F-35 and stand as a formidable competitor to Chinese and Russian stealth fighters. Lockheed Martin's involvement will extend to consulting on radar-absorbent materials, drawing on their knowledge from developing the F-22 and F-35 fighters. This collaborative effort aims to enhance the radar cross-section reduction techniques incorporated in the new Japanese stealth fighter. Turning to Northrop Grumman, Japan is seeking insights into sensor and networked warfare technology, which are prominent features in Grumman's Super Hornet jets. E-2D Advanced Hawkeye Airborne Early Warning and Control Planes, and the F-35's Distributed Aperture System multisensor. The focus on these advanced technologies underscores Japan's commitment to staying at the forefront of airborne warfare capabilities. Mitsubishi Electric's role in the project will center on mission systems and electronic warfare capabilities, particularly in the domain of self-defense jamming. This strategic partnership aims to integrate Mitsubishi Electric's expertise in these areas into the development of the new fighter. Although the fundamental design, including the airframe and engine, is already settled, the prototype is expected in 2024. With its maiden flight scheduled for 2028, serial production of the FX is set for 203 WS. Intending to deliver 90 advanced stealth fighters to the Japanese Air Force in the mid-2030s, coinciding with the planned phasing out of the F-2 jet. This ambitious project positions Japan a generation ahead in fighter aircraft technology. The price tag for each FX fighter is anticipated to surpass 20 billion yen, or roughly $179 million, contributing to the overall FX program's projected cost of $45 billion for Japan. In addition to this, Japan signed a contract with Lockheed Martin, committing around $23 billion to acquire approximately 200 F-35s. The challenge ahead lies in determining whether Japan's defense sector can efficiently manage and fund these two expensive procurement endeavors at the same time. The successful execution of this project would definitely enhance Japan's Air Force. The coming years will reveal how effectively Japan navigates the financial complexities associated with these significant IFIC investments in its defense capabilities. For now, let's take a look at some of its designs. The FX is a twin-engine stealth fighter that prioritizes air superiority and incorporates advanced technologies developed in the present to prepare for future challenges. Notably, the use of electric actuators is a key feature in the fighter's design. These electric actuators will be employed in the control power and brake systems, replacing traditional hydraulic systems for reasons that are easy to understand. This design choice reflects the commitment to harnessing the latest advancements to ensure the FX fighter's effectiveness and adaptability, emphasizing its role as a state-of-the-art aircraft in the evolving landscape of military technology. These electric actuators offer flexibility to seamlessly integrate into the complex interior of the fighter jet. This grants developers the freedom to design the jet in the most efficient manner possible. The use of electric actuators not only allows for a design that fits the complex spaces within the fighter, but also brings additional advantages. One benefit is the enhanced mobility of the aircraft, alongside a reduction in weight despite its sizable airframe. To achieve a lightweight structure, the FX fighter is taking a unique approach by eliminating the use of fasteners. Instead, it would employ a technique that involves bonding composite materials together through adhesive molding, applied across the entire fuselage of the craft. Aluminium alloys and carbon fiber reinforced polymer are the materials of choice for the fuselage, due to their lightweight properties. This strategic selection enables the fighter to embrace innovative design methods, resulting in a significant reduction of the structural mass of its airframe by 11.6%. These advancements are achieved in a shorter period, 66% less time than traditional methods would take. This showcases Japan's commitment to not only developing an advanced technology but also efficiency in design and construction, ultimately contributing to its effectiveness as a modern and agile fighter aircraft. The FX design concept brings several advanced features to the table. These features are designed to serve multiple purposes, such as reducing radar cross-section and minimizing heat signature. To make the FX even stealthier, there are additional measures in place. One such measure involves the use of electromagnetic wave absorbers, which absorb waves that might give away the FX location. Metam materials, a kind of special material with unique properties not found in nature, also applied to enhance stealth. Additionally, the FX deploys ionized gas or plasma stealth technology, which helps further decrease its radar cross-section, while also contributing to weight reduction. In terms of protection, the FX will be equipped with heat shields and an integrated bonded structure. This structure is made from composite materials, providing durability and enabling the aircraft to cover substantial distances. This long-range capability allows for flexible basing, making it possible to operate from central Japanese islands. A distinctive aspect of the FX's capabilities is its ability to control up to 3 drones, known as loyal wingman-style drones. These drones follow a shared basic design referred to as the combat support unmanned aircraft. These drones can be configured either as sensor platforms or weapons-carrying missile mules. The introduction of these drones enhances the FX's offensive capability, while also significantly reducing the risk to the jet from potential enemy attacks. The X-2 has been a testing ground for various advanced technologies, and many of these are likely to make a reappearance in the FX as well. Notable among these innovations are the EMP-resistant fiber optic fly-by-wire avionics and self-repairing flight systems. These systems are designed to detect and automatically compensate for any damage to the aircraft's control surfaces, enhancing the FX's durability and reliability in the face of potential threats. The FX is set to incorporate integrated sensors aimed at improving its ability to detect stealth aircraft. These sensors include a highly sensitive infrared camera, an active electronically scanned array radar, and a radio frequency self-defense sensor. The AESA radar and the RF sensor both utilize gallium nitride to enhance their performance, contributing to the fighter's advanced detection capabilities. This combination of technologies results in a sophisticated system that can swiftly detect potential threats, such as opposing aircraft air-to-air missiles or surface-to-air missiles. The FX is equipped to respond promptly by deploying suitable countermeasures, minimizing its radar cross-section to reduce vulnerability to attacks. Additionally, the FX has serpentine air ducts and an internal weapon bay. These elements, along with the use of carbon-based electromagnetic wave absorbers on the air duct and engine, contribute to a reduction in radar reflection. The fighter also employs passive detection mechanisms to avoid the detection of its own radar emissions. It also possesses an advanced technology known as plasma stealth antenna, serving a dual purpose as both a communication device and a means to create temporary plasma. This plasma takes advantage of its unique characteristics, allowing the alteration of physical properties through electrical control. Discussions are underway between Japan and Rolls-Royce to finalize the engine for the FX fighter. While this decision is pending, the FX is set to be equipped with two XF9 engines, each providing 24,000 pounds of thrust in dry conditions and 33 pounds with afterburner. Ongoing developments aim to boost each engine's thrust production to an impressive 49,000 pounds. The remarkable features of the engine extend to its three-dimensional thrust vector nozzles. Capable of deflecting thrust up to 20 degrees in all directions, this characteristic elevates the super cruising fighter's maneuverability to impressive heights, enhancing its capabilities during flight. The FX's spacious interior, owing to its large size, enables it to carry up to 6 internal weapons, a significant achievement that goes beyond expectations. In addition to conventional kinetic weapons, the FX is equipped with a microwave weapon functioning similarly to a laser-directed energy weapon. This particular weapon serves the purpose of disrupting incoming missiles, enhancing the fighter's defensive capabilities. Activation of the microwave weapon is orchestrated by the onboard AESA radar, utilizing highly efficient electron tube amplifiers. To further augment its offensive capabilities and minimize risks to the manned jet, the FX will be complemented by drones functioning as loyal wingmen. These drones come in two versions visually resembling twins but serving distinct functions. One serves as a sensor carrier, scouting for targets, while the other engages in firing munitions and directing incoming missiles away from the main manned fighter. Japan is also exploring a high-speed data link technology called integrated fire control for fighters, with the potential to enable Japanese and even US fighters to synchronize sensor and missile targeting capabilities. This technology is anticipated to significantly improve the accuracy of beyond visual range missiles, enhancing the overall combat capabilities of the new stealth fighter. The IHI Corporation has been actively testing the XF91 low-bypass turbofan engines since 2018. These engines incorporate exotic materials to reduce size and increase heat tolerance to an impressive 1,800 degrees Celsius, while slightly less powerful than the F119 engines on the F-22 Raptor. The XF91s boast a slimmer profile and cumulatively generate 180 kilowatts more than any US fighter. In addition to advanced engines, Japan is exploring thrust vectoring nozzles for the XF91, enabling exceptionally tight maneuvers. Thrust vectoring is a feature found in the United States' F-22 and Russian S-30 and S-35 jets. China has also been testing thrust vectoring engines on its J-10 and J-20 fighters, highlighting the significance of this capability in modern air combat. The development of the FX's gallium nitrate AESA radar is spearheaded by electronics manufacturers Toshiba and the Fujitsu Group. This radar, known for its advanced capabilities, can be powered up to function as a microwave weapon against incoming missiles. It will be complemented by an infrared sensor and an electromagnetic sensor. The landing systems for the FX will be developed by Subaru, leveraging its expertise in aerospace components gained from building wings and landing gear for the Boeing 777 airliner. With all these capabilities, the Japanese FX is set to become one of the most powerful sixth-generation fighter jets. However, it's interesting to note that alongside developing this new fighter, Japan is investing in 2 squadrons of F-35B stealth jump jets and F-35 as from Lockheed Martin, totaling an amount of $23 billion. When combined with the substantial budget for the FX program, it forms a massive financial commitment. Yet there's a logical explanation for this significant investment. Japan faces a unique challenge with its numerous outlying bases on islands, which could be vulnerable if there were an attack from China. The F-35B, part of the recent purchase, not only operates from the Japanese Navy's new light aircraft carriers, but also has the capability to fly from small island airstrips. This strategic feature extends Japan's air power reach, covering the East China Sea all the way to the edge of Taiwan's airspace. The fighter is a single-engine aircraft with a distinctive propulsion system. It combines a swiveling engine nozzle with a downward blasting lift fan. This innovative design enables the 18-ton fighter to take off in a short distance, requiring less than 500 feet for a successful takeoff. Its unique feature has made it highly sought after by countries with small aircraft carriers, lacking catapults, as it is suitable for shipboard use. Moreover, its short takeoff capability is not limited to naval operations. In theory, this fighter can operate from short runways on remote islands. The planned deployment of this fighter jet includes operations from the Japan Maritime Self-Defense Forces' 8,814 feet long light carriers Itsuomo and Kaga. When not deployed at sea, these jump jets could be dispersed across small airstrips in the Okinawa and Sakashima island groups. The F-35 is a sophisticated and maintenance-intensive machine. Operating from island airfields would necessitate substantial manpower and support equipment. This is where the new fighter jet, the FX, comes into play. Anticipated for such defense missions, the FX will bring advanced capabilities to further strengthen Japan's air defense. Japan's expensive investment in the FX and the F-35 reflects a strategic approach to enhance its Air Force capabilities. While the F-35B addresses immediate needs for flexible deployment and coverage, the FX represents the future of Japanese air power with its advanced features, making it an important component in increasing the nation's security. Thanks for watching. While you're still here, click on the link appearing on your screen to watch another of our interesting videos. See you there.